Hey everyone, we are ready to get started. How is everyone doing today? I can see that a lot of you have already tuned in, and I'm super excited for the track. I'm gonna give us a few minutes for more folks to join in, but until then, how's everyone doing today? It is, I guess, Monday morning for most people and Sunday evening for others, but how's everyone doing? I'm watching the chat. I can already see a lot of you are excited. Let me know if you need me to share the check-in link again. Where are you joining us from? Let's do a quick check. Where is everyone joining us from? So I'm joining in from Pune, India. Where are others joining us from? India, great. Kunal Gupta is also from India, great. 9:30 a.m. my end as well, so great. India, great. Makes sense, though, I guess. Oh, you're joining us from Canada. That's awesome. I'm a little confused regarding the timing though, because I assumed it was much later. But good for you. That's not very late, I guess. Then, all right. So today we're going to be doing embedded systems. So it's a very light intro into embedded systems. We'll just cover the very basics. So something as basic as what is an embedded system, and we'll do a short crash course with C, so that the next two sessions, which are going to be super fun because we're going to dive into some really in-depth concepts of embedded systems, like tool chains, how do you set up an entire project from scratch, how do you set up, we'll be mostly be working with Zephyr. I'll walk you through the installation, and yeah, it's going to be fun. We're going to understand some scheduling, some prototyping, and my favorite that I covered last in my last streams as well, which is a little bit of product development. Uh, Last LHD, if you all weren't there, I did a meta track on IoT in which we covered a lot of concepts like protocols and wireless systems. Do check that out if you want. But yeah, any questions are welcome. I will be sharing a repository with every piece of code that we write today. So I'll share the link to the repository right now. It's empty, so that you all do it with me. And then once every time after the session, I will push all the code that we write right in front of you all, so that you all have access to the latest code that we write. Awesome. So I can see people here are super excited. Hi, Just Coder, for something that I cannot pronounce, but feel free to drop in your names. I'm happy to call you by your names. Hi, Prateek. I hope you're the same Prateek we did our Hacker Hangouts with. So glad to see you here. That is a great question, Abhishek. So you submit your challenges on DevPost. Let me see if I can quickly find a link for you and drop it here. But I think all the links are available on Discord as well. And let's see if I can quickly drop the link for you. DevPost. This is Global Hack Day 1. Let's see. There we go. Found you. So the link that I'm dropping is where you can submit all your challenges and where you'll get your points from. Now there are two dev post links. One that is valid for the entire week, and this is for day 1. Let me drop you the entire week dev post as well. And from there, I think you can read out to the different days. That might be helpful. So let me quickly see. Yep, there you go. All right, great. So, are there any questions until then that you all want to start? Okay, I think we can get started. Let me quickly add my presentation to the stream. And yeah, There we go. Let's see if it starts. Okay. Alright, so let's do some quick intros and icebreakers for the ones who joined me last LHD, which was in January. You know what we do. I'm going to ask you the question that we're going to be answering in the session, which is embedded systems. So, what is the first word that comes to your mind when you hear the word embedded systems? It can be anything. There's no right and wrong answers. It's just me getting a perspective, and us trying to build a perspective wall as to what people really feel when they think about embedded systems. So, the first word that comes to your head when you think about the embedded systems, it can be a picture, it can be a device that comes to your head. Let's go. I am watching the chat section, and let's see what you all think embedded systems is all about. C, that is a great answer considering I spoke intensely about C. So, yes, C is a great answer. Embedded systems, well, now it has a lot of options, including JavaScript, but yeah, it mainly runs in C. Most production code is in C, C, majorly. Your Arduino IDE runs on embedded C. Rust, great. Not You're very close actually. Any embedded engineer who's already done a lot of production work will say embedded C and Rust go, both of them. And OS assembly, great. These are the exact words we're looking at. We're going to cover intensely or rather extensively what OS or an embedded system uses. So yeah, you're perfectly on the right track. This is another great answer. Integrating two systems. That's a very interesting perspective. And yeah, we're going to learn more. Any more answers regarding embedded systems? What do you see? So the more you learn about something, the more you have an intuitive idea about the other things that you learn. So let's say when you learn one, say web development, right? You're not just learning JavaScript. You're learning JavaScript. You're learning a little bit of Git. You're learning a little bit of API pulling, even if you're not using it, because when you're going through the articles and you're kind of developing an intuitive approach towards learning things. The same, which is why this activity I feel is really nice. Kind of build a perspective and make sure that you're consciously building your learning towards the subject. So I see another question which says, all right, so Abhishek, how about you remind me this again at the end of the stream? I will show while I'm pushing my code, I can show you how to do the dev post submission. Sounds good, because I'll have to log into my account and I'll do that in the end. Sounds good? So I will help you out there. Also, if you're in a rush, feel free to create a ticket in our server. Some of the coaches will definitely help you out. But yeah, at the end of the stream today, I'll definitely show you how to do a dev post submission to one of the challenges. All right, awesome, great. So let's get started right away. All right, so we've done intros and icebreakers. Well, we did icebreakers. Let me quickly introduce myself. So, hello everyone. I am Ritvi. Y'all have seen me in the Jan streams as well. I did an IoT track, and I do have a pretty extensive background in both IoT and embedded systems. Well, they're kind of the same thing and yet very different, and we'll see how when we start learning. And I've done multiple internships in this field with different types of businesses, which is a very interesting way to go about learning something. Any subject that you take, if you change the type of business you're working with, say so as simple as web development to something as complicated as production code for a software application, the type of business will influence the way you write code, the speed at which you write the code, and everything. Utsav has a great comment here. Oh yeah, so this is my artwork that I'm showing off. I'll be doing a stream on art plus technology too this week, so do tune in. I love mixing things up. We did one last LHD as well. So this is going to be fun. All right, so great. So I am a very passionate community builder and leader. I am involved in a couple of other communities as well. I know we see a lot of common people. So MLSA is where I'm involved a little more. That's called Microsoft Learn Student Ambassadors, and a lot of city communities in my city, which is Pune. So if you're in Pune, definitely, if you're part of community, you'll probably find me in the same circles. I've participated in a lot of hackathons, and yeah, so this is me. Feel free to ask me questions regarding any of these things and anything else, I'm happy to connect you with the right people as well. All right, so feel free to reach out to me on any of these social media networks. I'm pretty active in terms of replying. I don't post often, but yes, you can find me anywhere here. I'm also on Discord. So yes, let's move on. Session 1. This is a 3-part session, so we'll be covering a lot of things today. So we're going to cover what we're going to well, achieve after going through the 3 sessions. We're going to cover what is an embedded system. It's a very simple concept. I promise you, it won't take a lot of time. We'll look into the components of an embedded system. How do you, look at something and say, hey, this is an embedded system, right? Something as simple as that. We'll look into how do you get started into embedded systems, like apart from, attending these sessions or building. How do you stay put? How do you make sure that you're really developing yourself as if, embedded system engineer, rather than just, okay, I can code C for embedded systems, or I understand the electronics for embedded systems. A more wholesome way to keep at it, to keep learning. How do you read newsletters, which blogs do you read, and how do you keep yourself updated, because IoT and embedded systems is kind of ever evolving like any other technology, right? Then we're going to do C, which is kind of the highlight today. I want to spend as much time there because if you understand some very simple concepts of C, the concepts are going to be same over the languages. If you know any other language, this should be a very easy transition. We're going to look into loops. We're going to look into if else. Today it's just to get you, hands on with the syntax. Once you're comfortable with that, the next 2 sessions should be a cakewalk, because we're just going to look into real concepts, and if you understand the basic syntax, understanding the code should be fairly simple. All right, great. So let's move on. Again, Q&A and next steps are there, but I'm available throughout the week on Discord, so just tag me or reach out to me on any of the social media platforms, and I'm happy to help you out. All right. Okay, so what you're going to learn today, we're going to learn C programming, or rather what you're going to learn at the end of the 3 sessions, my bad. So C programming, RTOS, what's an RTOS, how do you code in RTOS, how do you get your RTOS connected to a cloud, what are the sensor signals? This is a very important topic, and during this, we're going to cover how do you read a data sheet, which is a very important session if you ever want to get into IoT or embedded systems, even remotely, because data sheets are literally the essence of, going about anything. If you're going to make a project, the first thing, regardless of what tutorial you're following, you're going to end up having a look at a data sheet. So how do you really read a data sheet? It can be a pretty complicated piece of paper, or it can be a very easy thing to get through. How do you make sure that you're reading the right information, and how can you be very efficient with it? That's basically what we're going to do in the next session majorly. All right, and how do you again continue your journey, basically keep at it, not give up after the session's end. All right, so what is an embedded system? So embedded system, I'll tell you what I think or what I imagine when someone tells me an embedded system. Embedded system is literally everywhere. So even before your smartwatches, your mobile phones, before the world became as electrical as it is, with our lights and everything, embedded systems were there. So from your washing machine to your refrigerators, your TV, they're all embedded systems. Any piece of electronics that goes into a device and does something on a regular interval, or does something on a scheduled manner, is your embedded system, which is where just to make sure that you have an intuitive connection, is where your RTOS comes in, which is your real time operating systems. Basically, you need to make sure that your system does something on an accurate time base, which is, let's say, every 5 minutes, every 5 seconds, or given your purpose of the system. Right, so let's look at a tad bit more technical definition of embedded systems. It's a combination of computer software and hardware, which is either fixed in capability or programmable. Well, now programmable, considering our world's become much smarter, our microcontrollers have become much advanced, but initially, like again, your washing machines that were there, or your TVs that initially came, they're embedded systems, and they had a very simple task, uh, either when you press a button, something happens, or every 5 minutes it does something. Your washing machine, for example, it has a circuit, right? Once you turn it on, once you press the button, it will wash for 20 minutes. For washing 20 minutes, it does not know that it's washing, right? It's basically a machine asking your barrel to kind of go or your motor to run for like 20 minutes. So how does it know it's 20 minutes? That's where your RTOS comes in, right? So that's basically your embedded systems. Now a little bit more feature wise, it can be either independent or a part of a large system. So washing machine, older washing machines, just independent embedded system. Now your smart washing machines, where you can connect your apps, you can connect it to your entire device or your home automation, they're part of a larger system, so that's entirely an embedded system as well, right? And well, it is mostly designed for a specific function, and if it's a larger function, you'll realize that there are multiple cores, which is basically multiple different brains of, or rather different embedded systems working together to do a bigger task at hand, right? So let me come up with a better example in a while when we cover RTOS, and you'll understand better. Any questions until now though? So, like I said, right, embedded systems at this point is everywhere, from your robotics, your home automation, your artificial intelligence, smart grid, smart cities. Everywhere you see, there's some kind of embedded system there, right? If it has a microcontroller that is basically the brain of a system, then it's an embedded system, right? Uh, any questions at this point? I am happy to answer any confusions at this point. If not, we can move forward. All right, let's move forward then. Okay. So, getting started with embedded systems, what are the things that you need to do to get started? And thank you, Pratik. What are the things that you can do to get started and make sure that you stay put, right? So a lot of y'all might be coming from core backgrounds, because I know I staff hackathons, I know you all are really into Python, I know some of you are very talented when it comes to web development. I see some beautiful CSS HTML codes every weekend. So how do you really keep at it, or how do you make sure that something so foreign at this point becomes more intuitive and more part of your learning? So, well, first of all, a good way to transition into some new technology is by using tools that you're already familiar with, right? So for example, I know you all do some amazing use of GitHub every weekend by pushing code, by collaborating with each other. So start with that, right? Start by making a repo on GitHub and trying to put your code there, because when you're dealing with something very very new, it's easier if you have something that works, right? No matter what, you'll be able to push your code even if the code does not work. So that's a good way to make sure that your conditioning does not fail you, to you don't give up very easily. Then it's a programming language. You don't have to directly switch on to C. I mean, today we'll be doing a crash course into C, but you don't have to go hardcore into it, right? Tomorrow when you pick up a microcontroller, you can start with something as good as using Python or circuit Python on your controller, and then slowly moving on to real bare metal programming, right? And there are so many tools out there to ease your transition into it. uh, Abhishek, is that a question regarding, do you want me to give you more examples of embedded systems? Let me know in the chat, and I'll definitely address it. I know there's a tad bit of a delay. Okay, that's your question. All right, yes. So yeah, washing machines, your TVs, what else, your laptops even, right? They're basically embedded systems. What better examples can I give you of embedded systems? Your robots, right? They're embedded systems. Any microcontroller that gets embedded into a bigger piece of machinery, or something that even remotely automates or schedules your tasks, is an embedded system. Does that make sense, Abhishek? I'm going to give you a moment to ponder and get back to me. So Abhishek, we're also, what the product development part where we do, where we'll oh, great question. So yeah, so when we do product development, basically I think halfway through the second session, what we'll do is we'll take a real life problem and we will try and solve it in the simplest way. So for example, let's say your problem is as simple as, you have two doors in your room and you want to know when you're coming up the stairs which one is open. So you have two LEDs and they need to kind of turn on and off based on whether the door is open. So you making a system for that is as good as making an embedded system, right? You're basically going to embed that thing into your wall or your door to make sure that you know. So we're going to have a microcontroller which uses some kind of scheduling or some kind of logic to make sure that you know. All right, give me just 1 second. I think my power is running out. So, all right. Uh, so Abhishek, did that answer your question? So what we'll do is we will make the circuit. We will also write code for it, and we will see if we can simulate. Absolutely, Abhishek. I will show you as many examples as I can. And I'm so glad you brought this up in this session. We have two more sessions to explore in depth, the different examples out there. All right. So when we even read data sheets, you'll get a very good understanding as to what we're trying to do. All right. Again, really, really appreciate all the people who are interacting with me on the chat. It really makes the whole live stream worth it. Thank you so much. All right. So let's right, so we were talking about the programming language. So again, you can ease into the entire embedded systems world. It does not have to be, tomorrow you have to give up on Java and JavaScript and just sit and learn C. That's not how it works. It can be a very nice, simple, easy transition. You can start with CPP if you're good at object oriented, and slowly come to C, which is more procedural language, right? Okay, open source projects. A lot of a great way, any great to start any new technology or to make sure that you stay put is being part of communities. And open source projects are a great way to do that, because once you take up an issue, there are people who are checking up on you, who are making sure you don't get stuck. And yeah, it's a lot of fun to get started with anything with open source. I know for a fact that we have all these three things happening in our global hack week. We have a github session. We also have an entire panel on open source projects, so you can ask questions regarding how to get started on open source hardware and open source embedded systems. So Yocto, Zephyr are some of the good examples of open source embedded systems. RTOS languages, which is basically used to develop embedded system. All right. Then there's basic electronics. This is essential if you want to get started with embedded systems. I write firmware, which is basically software for hardware, but even then, for debugging purposes, you need to know what's really happening on the board. I might not be able to design it from scratch, or it might take me a little while to understand what's going on. But to be able to debug my code, I need to understand what's happening on the hardware end. So that's where your basic electronics comes in. Choosing your design components. If you're building an embedded systems, you can't just take the first thing that comes into your hand, especially if you're building a product. And I stress, and I can never stress upon this enough, right? To really consider your module, to consider your optimization, whether you're choosing the right module is very important, right? And then comes learning through resources. For example, I am more of a, slow learner. I pace myself out. I don't like to go all in at once. So what I do is I start by subscribing to newsletters. So I know every day, I'm reminded a little bit that, hey, this thing exists. I need to study it. And then I'll join community. So there I'll see people posting their projects and I'm a little more motivated. And then I slowly transition into it. And I think that's a great way to go about it. I know a lot of you all work weekends and just build projects, which is amazing, and I would like to get there someday. But yeah, this is a great way to make sure that you don't lose out on the journey, or don't burn out quickly. All right, so that was getting started guide. We'll cover it more, and I'll keep giving you resource links as we go. So I'll be sharing a lot of resource links once we start the installation, what tutorials I use, and of course Stack Exchange is one of the best websites and resources to debug, right? Okay, so next is components of an embedded system. Again, very simple overview. We're going to do how do you really know something is an embedded system. So Abhishek, here again your question might play. So you can identify if your system has these components, it will qualify for an embedded system. All right, so let's look into what all these components are. All right, so first you have the hardware, then you have the firmware. Well, ideally these are the two only things that you need to consider for it to be an embedded system. But if you ever look at a product, and again, I always encourage people to do this, these three things, other things apart from these two things, when you keep thinking about them, when you analyze products, will really help you build better projects, right? So next is optimization. If you ever look at a good product, you'll see that there will be some kind of a optimization problem that they've solved. Cost will be optimized in terms of the modules that they've used. The purpose will be very simple. One product will solve a main purpose, and then there'll be a lot of other things that are kind of just add on, and that's why they might not be the best quality modules, they might not be the best quality or the best way to use that use case, right? So optimization priority is something very nice to observe whenever you're looking at a good product, be it as simple as a smart temperature sensor to your home automation products, right? Your smart bulb might not be the best at turning on or connecting to the Wi-Fi, but its purpose is very simple, to give you light, right? So it's okay if it's a little the module isn't the best, but the cost is optimized, right? So that's how you kind of go around observing products. Then there's sensor signals. What kind of signal is your bulb really giving out, right? If you're controlling the brightness, that means you can vary it through multiple uh, levels, right? If it's not, if it's just an on and off bulb, that means you're only giving it a digital pulse. So things like that, observing and looking at an embedded system is a good way to observe a system. The last one's cost, of course, because that tells you if it's a very good quality product at a low cost, you know that there's a huge amount of research and development that went into that product. All right. So again, hardware, there'll be basic electronics, there'll be transistors, resistors, capacitors, like any other microcontroller. If you have a simple microcontroller, even though that microcontroller will have these things, it will have a microcontroller. So apart from that, you will have a microcontroller, which is your brain of that system, controlling the entire system. Then you'll have firmware. The firmware will have an RTOS. Basically, it will have something scheduled. There might be logic. For example, your TV turning on a button press, that is logic. But otherwise, your washing machine, when you press the button, after that, the things it does, it's scheduled, right? It just knows. It does not know when the washing is over. You can put a sensor in, you can do it that way, but it does not do it, right? If 20 minutes, it's going to probably run the cycle and switch to the next cycle. Does it know whether the clothes are washed? Probably not, right? Mostly not. So that's your RTOS, basically your scheduling operating system, your real-time operating system. Then there's tool chains. Basically, if you look at the code and if you ever look at the entire project system that we'll look into, it's not just a code. It's not a simple script that we'll just run. It's going to be having an entire project system, which will also help you in optimizing your entire board. So every board, right? Your Arduino, your ESP32, your ESP8266, all of these are different kinds of boards. They all have different memories, they all have different optimizations within themselves. So how do you make sure that your script or your these big projects like Zephyr and Yocto, how do they make sure that they can support multiple boards? Because their tool chain, when you tell it that, hey, this is the board I'm building it for, it knows in its library that, okay, these are the optimizations I need to take care of. And then it will either build your script or it'll tell you that, hey, you're either using too much memory, or the time is not sufficient, or it cannot do so and so function, because probably the microcontroller does not support it, right? So that's where your tool chain come in. Then there's DevOps is true for any technology, right? So GitHub, being able to version control your system, being able to run a test to make sure that your code base is not breaking, your CI/CD, right? Continuous integration, continuous development. That's true for any technology, and hence also for embedded systems. More so for embedded systems, especially when you think about your the systems that go into your flight or your cars to kind of manage emergency situations, like your airbag, or when your flights have those masks pop in. Those are very timed things. It has to happen right on the time. If it doesn't, then it will the consequences are pretty bad, right? So the testing they're done to make sure that everything is in perfect check, and it's not breaking, is much more important, right? So DevOps is true for any technology that you learn, and hence also for embedded systems, right? Then, of course, optimization priority, we already spoke about that. Scheduling versus logic. Do you really want to make sure that your washing machine checks if every cloth of yours is being washed to a particular limit using whatever sensors? Maybe not, right? Because you know that after 20 minutes, you're good with the cleanliness that you're going to get. If you want a particular function to support that, then you maybe do that. But thinking from a product point of view, which is better, scheduling or logic? Scheduling, right? So things like that, performance versus memory, where do you want to really use a lot of, you don't need machine learning everywhere. You can put machine learning in your washing machine, but you really need it. You really need to make sure it's happening that way or it's processing that much data. No, right? So that's again performance versus memory. You're going to prefer that the 20-minute cycle runs flawlessly, that motor runs flawlessly, the motor driver has perfect signals, rather than wasting your memory and functions on maybe detecting the cloth's color and things like that, right? Then there's the sensor signals. We already spoke about that. And again, cost, right? These are more technical pointers from a product point of view. Device parameters. Can the machine survive in outdoor conditions? Material use and user obstructions. Is it okay if it gets harsh sunlight? Will your system inside, how much temperature can it take? If the system can take it, can the sensors really take it? Things like that. And of course, optimization priority. Again, size versus material versus the use cases, right? So your optimization priority, we've already discussed three different types of optimization priorities. All right. All right, so that was an overview into embedded systems. If there is any question at this point, let me know. Otherwise, I'm going to simply go through the slides very quickly and then we'll actually start coding. So, data types, we'll see the constraints of data types. What do you mean by this? When that we say, right, a data type has a range. It has a negative number, positive number, it can take so many numbers. Does it really matter? So, we look into data types, how it really affects your logic and your memory. We'll look into if else conditions, right? First, we'll go through the installation, of course, and print hello world because that's the tradition of us as programmers, right? Uh, and conditional statements, functions, very simple, how do you define a function, how do you use a recursive function, and storage classes are pretty important. I feel they don't give enough importance, or you're not taught that well anywhere if you're learning. But as an embedded engineer, storage classes is important because that will define how and where your variables and the scope of variables outside your script can be used. All right. So one of you already knows. So Kunal Gupta, thank you so much for telling me this. I know now that you can help out in the chat. So I'm looking forward to seeing your contribution there. All right. Is there anyone else who has any questions at this point? Otherwise, I'm gonna quickly go through the slides. We're gonna discuss very, very briefly, and then we'll actually start coding. And every code that we write today will be shared on GitHub, via GitHub rather. And I'll post the link again. I'll post the link right away actually. But the GitHub link is empty right now because I'll be pushing everything before you all, along with the PPT, of course, as soon as we're done. So let me quickly find the link for you all and post it. Okay, so I'm posting the GitHub link. It's empty again. I'll be pushing it right after we're done coding. All right, I'll also be pushing the PPT in front of you all, so that way, if we make any changes to the PPT, or if you all want me to add something to the PPT, it's the updated and the latest version according to what you need. All right. So, any questions at this point? Anyone stuck? Anyone not sure what we're still doing? We can definitely catch you up before we move on. All right. We have another good 45 minutes left. We'll take it nice and easy. If there's any questions anyone has, we'll go. All right. So let's start with how do you know whether your C program will run on your computer. So a simple check is open your command prompt, or if you're using a Linux, open terminal. Although if you're using Linux, I am very sure you all have a GCC compiler, so you all don't have to worry about it. But if you don't, if you have a Windows or a Mac, just open your command prompt and type in GCC and press enter. It will mostly throw an error, but if it detects what GCC is, you're good to go. So what I'll do is I'll quickly share my command prompt and show you what error it's going to throw. And if you get the same error, then that means you have GCC installed. So let me quickly share. Alright, so this is the error that you should get once you put in GCC. If you're getting this error, That means you have GCC installed. If not, then we'll have to install GCC. If you need the installation link, I'll quickly pop that in for you all in the chat. Mm-mm. So I'm putting in the link to install GCC in case you all don't have it. But I'm pretty sure if you've used nowadays even Windows, if you're updating it, GCC is usually there. But if not, let me know. I'm happy to show you how to install it as well very quickly. But you all should be good otherwise. Alright, so while you all figure out the installation, let me know if you need me to help you with it at any point, and I'll quickly go back to the PPT and walk you through how it works. So if you've not done programming on the code editor directly, basically you don't need a code editor today. We're going to be doing very simple coding, so you can use a notepad. But yes, eventually, I am not sure. Let me quickly check if it will. Well, yes, it says it will work. So you need to install GCC on Cygwin, is what I'm understanding. But if you want to share your screen later and maybe walk me through how you use Cygwin, I can maybe help you out. So here's the thing, right? If you have GCC installed, there is a particular way to kind of compile it and then generate the output code. If you know how Cygwin generates the output code, yes, you're good to install GCC onto Cygwin. But otherwise, we'll have to look into it, and let's debug together if you can't figure it out. All right. But yes, from what I'm looking at, I GCC should work fine with Cygwin. Does that answer your question, Squatcher? All right. So awesome. Great. So I'll keep checking on you in case you get stuck anywhere. I'll be happy to get you on Steam and have you share your screen, and while we debug together. All right. Great. So first, you need to install GCC, of course. Once you install GCC, which is GNU Cross Compiler, you need to open a new file. Now, this new file does not have to be in a code editor today because we're doing basic coding, but eventually it will be nice if you all have a code editor. I usually use VS Code, but you can use whatever you're comfortable with, from Sublime to an IDE even works well. All right. So we're going to open a new file. We're going to add the headers. We're going to add the main function, and we're going to run the program. So adding headers and just the main function should be good enough for your program to compile. You might not get any output, but it's good enough to start your program. And of course, we'll print hello world at the very start. So I just want to take a quick check as to whoever is following along. Do you want me to wait while you check or install GCC, or should we move on? Because I'm pretty sure you'll catch up with the hello world anyway. So all right, since no one's replying, I'm assuming everyone's with me. In case you all have any questions, again, interrupt me, stop me. Awesome. Okay. I see a capital. Move on. So I'll get going. Right. So the code that you're looking at right now is your very basic C code, right? So you first have your header, which is hashtag include stdio.h, which is your standard output library, all right, which is your preprocessor directive. Then you have your int main. Now, int main is your main function. It does not have to be int main. If it is an int main, make sure you return a zero. It won't throw an error, but if you're using an IDE, you'll definitely see a warning. All right. So if you don't want to return zero for whatever reasons, you can always use a void main, but usually an integer main is a nice way to go about it because it makes sure that your ending is proper, as in, you have a very logical ending to your code. If you ever make a flow chart or a diagram of your algorithm or your code, you'll realize why it's always a good idea to have an integer main at this point and return a zero to make sure that it's logically ended. Your code or your It's a great thing that happens at the back end with the compiler, and I urge you all to look at it. If you all want, I can cover it in the next session. So basically, how your code gets organized, when your compiler comes into the picture, and how it takes a different code and organizes it in the sequence. That's when this int main and return zero is kind of important. All right. Okay. So I'm gonna let everyone look at this and move on, so that if you all have any questions regarding this, though, feel free to ask. All right. Right. So moving on. Data types. Again, I mentioned why data types are important. Exactly. So basically, the program's over, right? And you have a -1 for error code. So you all know pretty well the back end of it, which is great. So data types, right? So you have char or signed character and your unsigned character. What's the difference, and does it really make a difference? Well, yes, it does. It makes a lot of difference. Especially if you're using an integer and you try and assign a negative value to an unsigned integer, it is going to cause a problem. You won't get the negative value assigned, rather, you'll get the positive value assigned. And why bother using signed and unsigned? Well, you can see the data is the same, but if, let's say, you're running a loop or you're running a huge scheduling algorithm, that's where unsigned integer and signed integers come into being. For example, if you're using a signed integer, you have -128 to 127, right? Now, let's say you want to count till from 0 to 255, right? But you want to use only 2 bytes. How do you do that? You're going to use an unsigned integer. That way, you're going to get the signed integers negative values also available as positive values for you to count. All right. So that is where this comes into being. All right. So then you have your long int, signed long int, again unsigned signed concept remains the same. All right. Then you have a float, a double, and a long double. Right. Again, we'll also look into signed 8 bits, 16 bits value, and you will see how much of a difference it can make. I have done this mistake at an internship, and I can assure you, being aware of your data types can really pay off when especially you're writing bigger algorithms, right? We were supposed to use a color sensor, and the color sensor was supposed to return the value of a denomination, all right? And I was supposed to get a value of 500, and to save memory we were trying to optimize the integers that we're using, and I was using an uint 8, and obviously it didn't count till 500, and we couldn't figure out because it was giving a random value at that point where it was supposed to return a 500. So yes, your data types and understanding their sizes and their ranges is pretty important if you're writing algorithms and you need to optimize it in at the end of your as a product. So pay attention here. If you have any questions, if you're not sure why it's happening, let me know. All right. Great. So conditional statements and loops, we'll look into this in just one moment. I'll be writing code directly. Let's look at this. Storage classes, again, very important if you're writing a bigger piece of code. For example, again, if the products that we work on at internships, they're huge ass products, right? So what you want is, let's say, your one dot, you break the code into lots of files, right? Like at least 5 to 6 files, right? And you want some variables to be accessible by all the files. How do you really make sure that all the files access that variable? So this is where storage class comes into being, right? So auto is your default storage, of course. Then you have extern, which is your global variable. This is very important because extern makes sure that if you define an extern variable in one file, it's accessible to the other files as well. All right. You all know static variable. It's a local variable which is also capable of returning a value when the control is transferred into a function, right? So that's a simple variable. Then you have a register, which is a variable stored inside a register. All right. You usually don't end up using register, but you will use external a lot if you go into a production code base. So be aware of the difference, and it really it's one of the small things that makes you different from an embedded C programmer to a C programmer, right? All right, so let's look into our code now. I'm going to stop sharing the screen and I'm going to share my VS Code. Okay. So I'll be making a new file from scratch before you all, so that you all can see. And I see a lot of questions regarding the type. It does depend on the compiler too, but remember that from embedded point of view, most embedded systems, or rather the programming language, you'll end up using not the language really, but more like the system. For example, you will either end up using CubeMX, or if you're using Zephyr, or if you're using Yocto, they have mostly standardized optimizations and standardized values, right? So again, if you're coding just C, it might change, but on a embedded systems level, it's going to remain the same, which is what I showed on the screen. All right. So if there are any more questions, let me know. If not, we can move on. All right. So, all right. I am hoping my screen's visible to you all. All right. Is my screen visible? I'm gonna wait exactly 1 minute for you all to give me an answer. Awesome. So Kanal's telling me it is visible, which is great. So here's what we're gonna do. Alright. It's better visible now, I can tell. Alright, okay. So we're gonna start by adding our header that we said was needs to be added anyway, right? So we're gonna add a hashtag include. Do you all remember what the header was? It was standard input at output, which is stdio.h. All right. Then remember we have our main, so we're gonna have our int main. Remember void also work. We're not giving any arguments. The empty parenthesis means we have no arguments, and then we're gonna print what every new program is supposed to print. There you go. Even this knows. So again, I'm using an autocomplete. You don't have to use it. You can write the entire thing yourself. Now, it won't throw an error again, but because we have initialized it as a integer function, let's return a 0 to make sure it knows that it's ended properly. Alright, so let's save this and make a new folder here. Test C codes. Right. Hello world. It's already detected that it's C because I'm writing it in VS Code. And there you go. So how do you run it now? Alright. So if you all have VCC already available, this should be a fairly simple process. If you all are installing VCC, let me know. I'm happy to help you with that. Alright. So CD into the folder that I just made. So let's put that C codes. There we are. Now let's make sure that our code's in the same folder where I'll be running the compiler. It should be able to detect the program file, right? So we're going to do gcc tab if that's the only file. If you do not have that only file, just type in a couple of letters and press tab. It should autocomplete. And there you go, it's compiled. How do you know it's compiled? So if you see, I ran a dir here and there were only these files, right? You don't see any files. Now if I run a dir, there should be an output file, an executable file right now. So let's do a dir again. And there you see this? There you go. So you have an executable file now. Let's just run the executable file. And there you go. That is your first program. If you're running with us, congratulations. Now you can add C to your resume. But yes, stick along if you want to really learn how to continue with C. So is everyone on the same page till now? Is anyone having trouble running any of these steps? I am happy to show it again. I'm going to give you all exactly a minute to follow along. If you've done this before, great. If you've never done it through command line, I've used IDE. I urge you all to give this a shot. Yes, I did change the directory into the working directory. So, what I mean by working directory is where your program file is. It does not, there's no particular structure that you need to write now because you're running single files. We'll study the structure later. But yes, I just changed into my working directory. If you want, I'll quickly walk you through it. So, over here, we were in my main users Ritvi user folder. Then I cd'd, which is changed directly into test C codes, which I did create while saving this file. Okay, then I did a dir, which means that only one file was there, right? That was just hello C world, and then we moved on to GCC. We compiled it, and then we had an output file. Does that make sense, Abhishek? Well, I think that's a great attitude, Kunal, for sure. I still remember learning C in my first year and being good at it and thinking, I know programming. But yes, it's a beautiful journey. It's a great learning curve. It's definitely fun when you make mistakes the way I did and learn the hard way to really respect data types and their ranges. But yes, definitely a great attitude to have, Kunal. All right, Abhishek, are you on the same page yet? Do you need me to show you how I went through the entire thing again? I am happy to wait because once you get the hang of the syntax, the rest of it is cakewalk. I know you all can just do it in like 10-15 minutes. I'm not even worried. I'm gonna wait for whoever's following along. I know a lot of you all are because I got a lot of move ons. So let me know as soon as you're done and we'll move on to slightly complicated concepts, but I'm sure you'll handle it without any problems. So a couple of things to note here while we're waiting for people to reply is semicolons. C needs you to have a semicolon if you're a Python programmer. I know you're not going to like C lot for this, but it's definitely a great habit that you build over time because a lot of other languages use semicolons. Then you have a printf, which is basically your console.log in JavaScript and just print in Python, if I'm right. All right, I love the enthusiasm Yash has, and I am totally gonna use that to continue. All right, so what do you want to do next, right? We have done a hello world. We've printed a string by literally typing it into the colons. Let's move on. So let's move on to defining data types. How do you define data types, and what did I mean when I said what will happen if you use the range outside the given range, right? So if I'm doing an unsigned integer, which is uint, all right. Next, I want an 8-bit integer, so I'll do a uint 8, and there we go, it's completed. So initially, I've assigned uint 8 bits to be 0. Now, what will happen if I assign it 500 and try to print? Any guesses what's going to happen if I do that? Shriyansh, absolutely. Feel free to use C++. What I am going to do is, I was expecting this question, which is why I have code files for CPP ready as well. And a lot of embedded platforms do use CPP. And if you're coming from an object-oriented background, I think CPP will be easier for you. So feel free to use that. I will make sure that you have code files by the end of today to kind of parallelly run through. But when I will be doing Zephyr, we will be sticking to .c source files, which is where you can kind of try and follow along today. But yes, feel free to use CPP. Very much okay. Also, if you look at Arduino, the .ino files kind of convert to CPP as well. So you're good to go. If you want to follow along in Arduino, what we do in Zephyr, you're welcome to do that. All right. Great. So what will happen if I give uint 8-bit a 500 value? Fun stuff happens when you do. So I'm going to do that, right? I'm going to give I'm going to let hello world print for that matter. Let's let our hello world stay. Then we're going to give I equal to 500 semicolon. Remember semicolon. Then we're going to do a print f. Now this is the fun part because this is where you learn how to print variables, right? And there's my autocomplete. But basically what you want to do is a percentage. which now tells the program that, hey, I'm going to be giving you a variable. Next you're going to give the variable type. So D is for integers. If you want to print your string, you give a character percentage C, which basically means character. And if you want to print a float, you accordingly change your data type values. I can see that. All right, great. Alright, so this percentage basically percentage data type is what you're going to give. A slash n is a new line character. I'm sure you all are aware of this as well. But if not, a slash n makes sure that the next character gets printed onto the next line. Right? It's a new line character. And then is your variable that you're printing. Also remember, the percentage d needs to come inside the double quotes. Alright. Great. So, what do you think will happen? Any guesses? I can't see. Oh, you want me to increase the font size? My bad. Let me increase the font size to make sure you all are comfortable. Is this better, Yash? And that is a great catch, Agastya. Thank you so much for pointing it out. I will do that. But integers mainly use percentage d. If you're in an embedded system environment, it will show an error. It will tell you that, hey, this is an incompatible data type. So let's look at that as well, okay? I would have changed it once it threw an error, but thank you so much for pointing out. So let me make that mistake. Let's see what's the error that our compiler gives, and we'll move on. All right. Let me know, Yash, at any point if it's again uncomfortable. I'm happy to change the entire environment, or maybe show the code in a different code editor, if that makes sense, right? Great. So let's compile this code now because we're using the same. I'm just going to do a CTR. It's save, and then we're going to go. We're going to do the same thing. GCC. What's the name of our code? It's hello world. So let's do that. Hello world. See, there we go. And Agastya was right. It's giving us an error which says incompatible data type IDD. Yep. Also, because this is a different environment, it needs us to put a W. Let me check why though. Okay, let's put a dot U here and see if it gets rid of the error, because the error is not what I was expecting. But let's see. Did I lose my terminal? Not that my terminal. There you go. Still the same error, which is very weird. Okay, this is weird. I am not expecting this error because I know it does not come in your embedded system project. I'm not sure why it's throwing this error here. So let's stick to W. I'm not sure why it's asking me to do a wide character though. Let's see what happens when we do that. Yep, it's a very different error. I am not expecting this. So let's go stick to printing data types for the time being. Actually, Augusta, it should give me this regardless of me adding std I know that for a fact, but I will take a suggestion into consideration and see if that helps. Yeah, there we go. So it's an overflow. Again, this is not what happens, especially if you're using a high level compiler tomorrow when we look into the embedded system codes. Exactly, because of the OS, because your project will already have a lot of libraries that it's inputting because of your board that we select. So this won't happen, I promise you tomorrow. But yes, this is a great learning for all of us. I haven't written pure C in ages. Actually, never after first year of college, which is great for me because I'm also revising. But yes, so tomorrow when we use, we won't be including this. We'll only include this. Actually, we won't be including this either because your again backend library will take care of this. And there we go. So this works again. It's throwing an error. Tomorrow it won't throw you an error. It will give you a random value because what happens is in your microcontroller, it does not have the time to throw you an error. All right. So what it's going to do, it's going to roll over. What will happen is, so let's say 0 to 244, then it's going to start counting from 0 again, and whatever the value is at 500, it's going to give you that value, which can be a random integer given the timing, or it can be just that integer that it's giving after counting to that point. The same happens if you're using a signed integer. So if you have a signed integer and you allocated a value more or less, it's not going to throw you an error. It's going to just roll over. It's going to count again from the point on and give you that number. Especially if you're using an STMcube IDE or Zephyr, this is what's going to happen. You do not get these errors. Your compiler is not this stringent in your embedded systems. You can make it stringent. We'll see how. But usually when you're working in a bigger code base, you don't make it that stringent. All right. So yeah, but yeah, this is why knowing your data types is again very important. All right. Okay, so moving on. Now you understand data types. You know that if you want to use an unsigned integer or any integer with basically controlled, optimized value, you want to include this only if you're doing pure C. And there is an error here. Okay, great. Okay, so let's move on to our next thing, which is your next data type again. So the same thing applies for float and characters and doubles and longs. So let's just quickly declare a float and see how that works. Okay, float. Also, just side note is if you're going to use float, usually to declare it 0 or 0.0 is not the correct way to go about it. It's 0.0f. Again, that won't make a difference in the longer run, and especially if you're writing code for embedded systems, it's a bigger code base, it won't throw an error. But yes, it's always a good idea to be aware of what's happening. Right over here, let's make this f time. Let's do this is hello world. Let's do and a.exe, and there you go. Right. So this is how you basically go around printing different data types. This is how you use different data types. The different operations on a data type also remain the same. So addition will basically add it. Subtraction, if it's a negative value, again, if you're using unsigned, it won't give it a negative value. It will, if you're using pure C, throw an error. If not, if you're using an embedded system, it will just roll over and give you a positive value. All right. That's I think it on the data types end. If you all have any questions regarding data types, feel free to ask me now or tomorrow. We'll again when we're declaring stuff for our LEDs and making sure that everything works logic, we'll go over it again. All right. Moving on to conditional statements. So conditional statements are again same as your any other language. You have if and else, and you have else if. So we'll just quickly write simple logics and print stuff to make sure that we understand the concept. The repository, though, will contain very detailed examples of everything separately. So you have a hello world working differently, you have if else working differently, you have loops, every type of loop defined differently. So don't worry about that. Let's give it 15 more minutes today, and after that, I'll push all the code so that you all are aware of how it works. And I'll also give you a couple of links for installations in the repository in a bit. All right. Okay, so moving on to if and else, let's try and print if I is equal to this, else, or rather after we assign it a new value, else. Let's just first try if and see how it works. So commenting in C is double forward slashes. If you want to do a multi-line comment, you do a slash star slash. Now here's the thing, right? A lot of people, like even I, don't use multi-line comment except if I'm writing an entire chunk of paragraph to kind of define what I'm doing. What I prefer doing is, especially since I'm using VS Code, I just select the entire chunk of my code, and I just go control forward slash, and it usually just comments or uncomments my code, right? That's how usually it's a much optimized way to use it. That is a great question. So yes, we'll be covering all these operators. So what you're talking about, if anyone does not know, Yash is talking about the conditional expression. We'll cover that as well in just 2 minutes. Let's just start with a simple if else, and then I'll come to the conditional statement. Alright. So you have if so and so. Let's comment these two lines. We'll come back to this later, and let's get rid of this as well. Oh, okay. So let's save terminal. Here we go. So you have hello world being printed if this is equal. Now let's change this. If I equals to 2, that means this shouldn't work, right? So we're gonna go hello world, and I'm gonna do it didn't print. That means your if else if I is equal to was returned as false. Alright. So now let's change this back to what it was, and let's do else I is not equal to 0, f. We don't want a hello world, we want it to print the value of f. So let's just take this chunk of data and add it here. Okay. Mm, there we go. So let's add this as well below after that we're changing this so that it returns true. Alright. Now this should oh, yep, it worked. And then there was an else as well, but because this was true, it didn't come here, which is a great example for us. Now let's get rid of this and see what happens. There you go. Right? So your if else works. Now let's look at the conditional expression that Yash asked us about. Let me quickly grab the conditional statement so that we can. All right. So what is a conditional statement? Basically, a conditional statement is if so and so, else so and so, and all reduced to one single line. It basically helps your code become a lot more readable and a lot more simple. So let's get rid of all of this chunk of data. Right, and let me put this. Right. So what we're basically doing here is all right. Much better. So C does not have a problem if you don't indent it. It has no problem at all, but it's always a good practice to format it if you want it to be a nice, readable, production-based code. All right. So what does this statement say? Anyone wants to take a guess as to what this statement is basically saying? So what the statement is basically saying is if x is greater than 6, y is equal to 6. Does that make sense? Else y is equal to x. Does that make sense? Perfect. This is perfect. Great job, Scotcher. Great. So this is basically a conditional expression, all right, and this is very useful, especially if you're writing a lot of if and else's. So another thing is, if you're writing a lot of if and else's, a good alternative is to use switch case, of course. But again, if you want to assign values very quickly and move through the algorithm, your conditional expression is a much better way to go about it. All right. So this was your if else. Now you can also have nested if else's. Basically, if this is so, then if this is so, else if this is so and so, and then just keep iterating through it. All right. Then of course you can have multiple combinations, right? You can have your integers rolling over inside your if else's. Then comes loops, right? So loops are basically again, if you've done any other language, you know there are three types of loops: do, while, and for. There's something called an entry control loop and an exit control loop. So let's write one of each. What do you mean by an entry control loop? Anyone wants to take a guess as to what's an entry control loop and what qualifies? Which of these qualify for entry control loops? Anyone? So we all know that there are three types of loops. If sorry, for, while, and do. Which ones are entry controlled and which ones are exit controlled? Great job, y'all. So Yash, both the Yashes got it correct. Yes, which checks at entry and which checks at starting. Great. And do while is an exit control loop. Amazing. Y'all are already such experts at the concepts. Let's just look at the syntax ones, because that's what we're doing today. We're just getting, comfortable with C as a language. So let's try and type in, or rather write a quick do while loop. So let's say we have an integer there. So do while. Let's make it shorter. Let's do it x less than 10. All right. Alright, so we have do y equal to x, x equal to y plus x, and then we're printing x while x is less than 10. Let's start with something simpler. Let's just increment the loop to see what's really happening. So x equal to x plus 1 while x is less than 10, right? So let's save this. Let's go GCC. There you go. So what just happened was it started at 3 because you did a do x equal to 3. So let's say if x was over here 11, right? What would happen is it would still do a plus 1 before exiting the loop, because we never checked any conditions before entering the loop. It will run this at least once before checking for any conditions. All right. This is your basically a sense of a exit control loop. All right. And then you have for and while, which is basically, so let's write a while x is less than 20. I'll leave everything as it is and just make this as x. Alright. So just in case you're wondering what's happening, this is my GitHub Autopilot running, and while it's not a very recommended way to code, it does not really help in your embedded systems anyway, because it does not know what it's doing, but it's a great way to kind of practice your syntax like I'm doing right now. Alright. So percentage dx, again, this is what we're defining. Let's see what happens here, right? So you have GCC hello world. Did we save it? We did save it. And then you have a.exe. So what happened was it first checked whether it was less than 20. So now this time if I make this 21, it won't run anything because it's a entry control loop. There you go. It didn't print anything, right? So this was a while. And now let's quickly look at for, and then we will basically close the session for C today. If there are any questions regarding you getting comfortable, I think just running all the codes that are uploaded to Git today will be a good way to go about it. Just try running them. If you have any trouble with GCC, also reach out to me. We'll close the session in like 8 more minutes, worst case. But so let's quickly run a for loop and see how it works. So here we go. For this is where you initialize it. So you can initialize your variable right here. So for me, I'm going to do int I equal to 5. Then it's going to be my condition, which is I can be less than anything. And it's already suggesting us stuff. So let's just go for that. So you have I less than equal to x, I plus plus until that happens. And when that happens, your y will be equal to I and it's going to print. So I plus plus will happen every time your loop is over. Now, can you tell me why would I ever initialize a variable here and not at the top? Why would I ever do that? I mean, I can initialize it here. Why would I ever initialize it just here? So the reason I would ever do that, and I always do that, especially if you're running a for loop in an embedded system or rather a OS, you're limiting the scope. Exactly. It's a great way to limit the scope to make sure that you can reuse that same variable, and that way there's less confusion. Else, if you ever do it at the top and there are lots of for loops, you're going to end up having an I, J, K, L, M, and that just goes on, right? Or you'll end up reinitializing them. So a good way to do it instead is to limit the scope by initializing them right there in the for. All right. Else, another way to do it if you're going to reuse the same variable is making it global. That is initializing it right at the top using int global. The example is already there in the GitHub code that I'll be uploading. So definitely go through that if you're not sure what I'm talking about. All right. Awesome. So let's just quickly do this, and we'll also see what happens if I do a print f what I. All right. Save. See what's wrong. There you go. That's why formatting is important. There you go. So there's an error because your I outside this is undefined. Alright. So let's quickly comment this and see how our for loop runs. And we should be good to go after that. There you go. And that's a for loop. It's checked until your I was less than equal to. So of course it checked for equal to x and then it ended. All right, folks. So that's it from us getting acquainted with C. What I'm going to do very quickly is right while we're here, push the code. So give me 1 minute while you can till then ask any questions if you have. We'll get started with in-depth RTOS concepts from the next session. We will cover a little bit of history of computers as to how embedded systems really evolved. It's a very interesting story. So we'll look into that for like 5 minutes. Then we'll move on to RTOS concepts. I will be giving you links of Zephyr in the GitHub repo, which should be updated by evening. So check by 8 p.m. today for sure if you're going to be following along. I would like you all to install Zephyr. because the reason I want you all to install Zephyr and really play around, because even Arduino works if you want to follow along just for the sake of coding and understanding the scheduling. The reason you want to do Zephyr is you really understand the amount of flexibility a system has, the amount of options available for you all to make the tiniest of the changes within a system, and how detailed the system is, and why reading a data sheet is actually that important. All right, so that would be really nice. Again, I'm waiting for questions. If there are any, feel free to ask. I'll also show you the unsigned integer part that I was talking about tomorrow in the actual code. If you have a microcontroller and you can follow along, great. If not, don't worry about it. We'll run codes that do not require a microcontroller just yet, so that you all get comfortable with the environment first. All right. So, what I'm also trying to do on my end is I'm trying to set up a remote kind of a board where you all can directly run it here on my controller. That way, you'll know if there is any memory issue that's happening, which is very interesting to see if you're working with an embedded system. So, I'll try and set that up by tomorrow, if not, definitely by the third session. And yeah, that's all for the time being. But feel free to stick around while I push the code. And if you all just want to ask any questions related to anything that we spoke about today, or you were expecting me to cover in the later sessions, let me share my PPT again. And there you go. So again, we'll be covering a lot more concepts in the next session, so stay tuned. And if you're sticking around for the push, do wait, I'll tell you. Yep, let's hope I can set that up by the third session for sure. I'll try and do it by tomorrow itself, but let's see. All right. Great. So any other question, let me know. I'm right here and I'm pushing the codes. So you all should be able to see all the codes that we spoke about today and more in like less than a minute. All right. So while my messages get committed, are there any other questions that you all have? It can be related to IoT, it can be related to anything that I spoke about or mentioned. I am happy to help you out. Also, Scorcher, you were using Sigwin. Did that work with GCC? I totally set my mind to ask you before, in case you're still around. All right. So, Scorcher, are you using Mac or Windows? Nice. I'll try out Sigwin and make sure that I can help you out there as well. I have never tried Sigwin yet, so I'll do that. But yeah, if you can get GCC onto your direct system, great. You can follow along in VS Code just as we do. But either way, we'll be doing Zephyr, so you shouldn't be worried about it. All right, so I think the codes are pushed. I would be really grateful if one of y'all can quickly check and tell me if y'all can see the codes on the repo. So I'll post all the other resources as well very soon regarding the Zephyr installation and the installation of GCC as well onto this repo itself. Right now, though, you all have access to all the codes that we almost ran. I don't see Hello World. I think I didn't save it in the right folder. I'll do that then. But apart from that, I think you all should be good to go in following the session. All right. Are there any other questions that I can answer? If not, folks, I'm gonna end the stream for today. I hope you all realize how vast this entire field is of embedded systems. I hope to see you all in the next stream tomorrow. It's at I think 4:30 p.m. IST, uh, which should be I think much later for you all who are joining in at 9 p.m. at your end. But the recordings will be available later, so don't worry. And the next session's earlier, so I think you'll be able to catch that. But yeah, I hope you all enjoyed today. This was definitely, I had a great time with everyone who was interacting. Thank you so much for interacting. That really, really makes the stream going. Thank you, Pratik. I hope you all can take away more from the next two sessions. Yeah, I'm going to end the broadcast now. See you all. I see a question, so I'll answer that before I go. So, I do not suggest an IDE, but if you really want to get started, there's something called platform.io. It's one of the most used tools, and you can also configure Zephyr in it. It's a great tool to get started with. So yes, it's a good way to go about it. I'll add the link to that as well in the repo. I'll quickly take a note for me. But apart from that, yeah, platform. Let me, quickly drop you a link as well. Ironically, I have platform.io installed, even though I don't exactly recommend people to install it. Uh, there you go. But it's a great way to get started. So there you go. That's your link to platform.io. It gets directly installed into your VS Code, so it runs out of the box. You have all the options available in VS Code. So it's a very fancy way to go about things. I actually have it installed. If you want, I'll give you a walkthrough about that as well in the next session. Oh, and if Abhishek is still around, do you want me to show you the dev post submission? I'm happy to do that. If not, I'll make sure that other coaches are aware that you might need some help there. All right, I guess Abhishek isn't around, but all right. So thank you so much. I'm glad you all enjoyed the session. I know it was supposed to be a light and a starter session. So next session is going to be a very heavy session in terms of terminology, in terms of the concepts that we cover. So come prepared, and yeah, I'll see you all tomorrow. Bye bye.